Hello, welcome to our presentation of the Weka analysis. In this coursework, we will be demonstrating our ability to analyse data for the offensive language on social media platforms. Here's the team. Offensive language is an ongoing problem within social media. Managing this is a big challenge for companies. Our objectives are to recognise whether a tweet is offensive, if it's targeted, and who it is targeted at, to hopefully maximise positive engagement on the platform. In order to do this, we need to convert the databases into Weka-compatible files, then explore Weka's wide range of classifiers and evaluate how well we succeeded in our findings.
The first dataset we will use in the Weka mining tool is the training data. This sample data is then used to train the model, which will be then tested using the test dataset. The test data contains a small sample of instances like those in the training set. This data will then be used to backtest the accuracy of the model we just generated using our training set. Here we can see a brief example of how the data looks in its raw format, with the defined attributes on the left and some example instances from the training set. After exploring the dataset, we noticed that there were no real underlying issues. However, upon initial import into Weka, it identified that there was a single duplicate entry, which was then manually removed.
To prepare the data, we had to remove the apostrophes from the tweets, then convert them to the ARF format, and then remove the duplicate data. Removing the apostrophes was done with the simple find and replace feature that we use on our text editor. We then converted the TSV files to ARF files using a program obtained from GitHub. And lastly, after converting the files appropriately, we noticed that there was duplicate data, so this was also removed from the files.
The string-to-word vector algorithm is a tool used to convert each string into a numerical attribute that Weka can recognize. The SMO algorithm breaks down the problem into a series of smaller problems, then works through each one individually. The J48 algorithm generates a series of decision trees, then uses cross-validation to estimate the error rate. The logistic algorithm is used to predict a value based solely on prior observation of a dataset. The random forest algorithm creates multiple decision trees and works out the average between them all.
Weka produces its own confusion matrix, which is already easy to understand. Our main focus of the evaluation was to look at the percentage of correctly identified instances in order to evaluate our model.
Here is a table of our results. The optimal classifier for task A was the SMO algorithm. However, it would not finish computation for tasks B and C. So therefore, we found the MBMU was the best for task B and the simple logistic was best for task C. And that's it for today. Thanks for watching, guys. Please like, comment and subscribe. PS